Welcome back. We are still on the topic graph of quadratic functions. In the previous video, we learned how to use the graph of a quadratic function to find the equation of the line of symmetry of the curve. In this video, we are going to learn how to use the graph of a quadratic function to find the gradient of the function at a point. Finding the gradient of the function at a point on the curve. Before we learn how to find the gradient of the function at a point on the curve, let's refresh our memories on finding the gradient of a straight line. In the videos on straight line, we learned how to find the gradient of a straight line. In those videos, we learned that if we have a linear function, let's say that we have this linear function y is equal to 2x plus 1, and we draw the graph of this linear function on a graph sheet, we are going to have a straight line. So we have the x-axis here, we have the y-axis here, and we have the graph of the straight line y is equal to 2x plus 1. We learned how to find the gradient of this straight line. We learned that to find the gradient of this straight line using the graph, you will need 2 points that fall on the graph. So let's pick 2 points that fall on this graph. You pick one here, and you pick another one here. You trace the first point to the x-axis, you trace it to the y-axis. Let's say that on the x-axis, the coordinate there is x1, and on the y-axis, the coordinate there is y1. So the coordinates of this point, we are going to call it point A, is x1, y1. You do the same thing for the second point. You trace it to the x-axis, you trace it to the y-axis. On the x-axis, the coordinate there is x2. On the y-axis, the coordinate there is y2. So the coordinates of this point, which we are going to call point B, is x2, y2. With the coordinates of these 2 points, we can find the gradient of the line y is equal to 2x plus 1 by using the formula gradient is equal to y2 minus y1 divided by x2 minus x1. We learned how to do this in the videos on straight lines. Now, let's learn how to find the gradient of a function at a point on the curve. I'm going to bring this line here so that we can continue at this side. So let's say that we draw the graph of a quadratic function and we have a curve like the one we have here. We have the x-axis here, we have the y-axis here, and this is the graph of the quadratic function. How do we find the gradient of the function at a point on the curve? Before we learn how to find the gradient of the function at a point on the curve, there's one important thing that you have to take note of. On a straight line, the gradient is always constant. So the gradient of a straight line is constant. It doesn't matter which points on the straight line that you pick, you are going to have the same gradient. The graph of a quadratic function is a curve. As we can clearly see, on a curve, the gradient or the slope is not constant. So the slope of the curve at this point will be different from the slope of the curve at this point, and it will be different from the slope of the curve at this point. So at different points on the curve, the slope or the gradient will be different. Unlike a straight line where you get the same slope or gradient, on a curve, the slope or gradient depends on the point that you are on the curve. So if you are at this point on the curve, the slope or the gradient will be different from someone who is at this point on the curve. And at the same time, it will be different from someone who is at this point on the curve. So on the graph of a quadratic function like the one that we have here, you can only find the gradient of the function at a point on the curve. So for example, you can find the gradient of the function at this point, at this point, at this point, and at this point. This is because the gradient of the function at different points on the curve will be different. I hope that is clear. Now let's move on and learn how to find the gradient of the function at a point on the curve. To find the gradient of the function at a point on the curve, the first thing you have to do is to locate the point on the curve. So let's bring the graph of the quadratic function back. We have the x-axis here, we have the y-axis here, and this is the graph of the quadratic function. We are saying that to find the gradient of the function at a point on the curve, the first thing you have to do is to locate the point on the curve. Let's say that on this graph, we want to find the gradient of the function at the point x is equal to -3. So we have to locate the point x is equal to -3 on the curve. We have x is equal to -3. So you come to the x-axis and you locate -3. This is -3 on the x-axis. You can see that -3 on the x-axis does not fall on the curve. So you have to trace it to the curve. So you trace it downwards to meet the curve at this point. So at this point on the curve, x is equal to -3, as you can clearly see. After you have located the point on the curve, the next thing you have to do is to draw a tangent to the curve through the point. You draw a tangent to the curve through the point. Now we have met a new word here, tangent. Tangent. What is it? In the videos on plane geometry, we learned about a tangent. We learned that a tangent to a surface is a line drawn to touch the surface. Let's say that we have this circle here and there is a point on this circle. We are going to call that point point A. The tangent to this circle at point A is a line drawn to touch the circle at point A. So this line drawn to touch the circle at point A is known as a tangent. The point here says that to find the gradient of the function at a point, we have to locate the point on the curve, which we have done. Then we draw a tangent to the curve through the point. So we will draw a line that touches the curve through this point. So you draw a line that touches the curve through the point. Remember that the tangent does not cut the curve, it only touches the curve. So you draw a line that touches the curve through this point. Okay, after you have drawn the tangent, what do? You find the gradient of the tangent. So you find the gradient of this tangent. The tangent is a straight line, and we already know how to find the gradient of a straight line. So let's go ahead and do that. So you are going to pick 2 points that fall on the line. You will pick this one here, and you pick this one here. So you trace the first point to the x-axis, you trace it to the y-axis. You get the x-coordinate here, which you are going to call x1, and you get this one, which you are going to call y1. So the coordinates of this point will be x1, y1. You do the same thing for the second point. You trace it to the x-axis to get the x-coordinate. You trace it to the y-axis to get the y-coordinate. Let's say that the x-coordinate is x2 and the y-coordinate is y2. So the coordinates of this point is x2, y2. With the coordinates of these 2 points, we can find the gradient of the tangent by using the formula gradient is equal to y2 minus y1 divided by x2 minus x1. So with this formula and the coordinates of these 2 points, we can find the gradient of the tangent. The gradient of the function at a point is equal to the gradient of the tangent. So after we have found the gradient of the tangent, we are being told that the gradient of the function at the point is equal to the gradient of the tangent that passes through the point. So on this graph sheet, the gradient of the tangent that passes through the point x is equal to -3 is the same as the gradient of the function at the point x is equal to -3. So let's go over how to find the gradient of the function at a point. The first thing you have to do is to locate the point on the curve. So here we located x is equal to -3 on the x-axis, but it did not fall on the curve, so we have to trace it to the curve to meet it at this point. After we have located the point on the curve, you draw a tangent to the curve through the point. We have learned that a tangent to the curve is a straight line that touches the curve. So you draw a tangent to the curve through the point here. So here you draw a straight line that touches the curve at this point. After that, you find the gradient of the tangent. The tangent is a straight line, so you find the gradient of the straight line by picking 2 points that fall on the straight line. Then you read the x and y coordinates as you have done here. After getting the coordinates of these 2 points, you use the formula gradient is equal to y2 minus y1 divided by x2 minus x1. We are saying that the gradient of the function at the point is equal to the gradient of the tangent. So in this case, the gradient of the function at the point x is equal to minus 3 is the same as the gradient of the tangent to the curve that passes through the point x is equal to minus 3. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you have studied in this video to solve some questions. Bye bye.